So welcome once again. In my previous lesson, we discussed about the work done that is obtained from torque. Okay. So this next video, the video that I'm making right now, we are going to discuss about what? The field of a line of a charge. Okay. So before you can get the field of a line of a charge, you have to make some assumptions. Okay. And this assumption is just about, so we are supposing that a positive electric charge Q, this is distributed uniformly along a line or a rod, and the length of the rod is 2a, 2 times a. Okay, we have distributed the positive electric charges along this rod, which is the length 2a, and it is lying along the y-axis, which means that it is entirely in the y-axis between y is equal to what? Negative a, and y is equal to positive a. Regardless of the direction, which is the negative and positive, if you add a plus a, you are going to get 2a, which will still result in the what? In the length of the rod. Then determine the electric field at point P on the x-axis, okay, at a distance x from the origin. So something like this. This is all what they are trying to mean. This is the illustration, okay. So this is the y-axis, our negative y, positive y. This is the origin, and they've placed this rod, which it has been what? It has been charged positively. They've placed this rod entirely on the what? On the y-axis, and the length is what? 2a. So from the origin to where it ends is what? A, and from the origin to where it ends in the negative y direction is also a. Adding them up will give you what? 2a. Now they are saying that supposing there's a small change in the charge, and always keep in mind, the moment there's a small change in the charge, which is dq, there's a corresponding change in the electric field at point P. If there's a small change in electric charge, then there's a small change in what? Electric field or electric field. So here, this is our charge, our dq, and it is what? It is opposing what? A field. It's opposing an electric field here. And this point charge, at this point charge is usually positive, so it's going to repel it. Our point charges are normally represented with what? A positive charge. So here is going to repel it according to laws of charges, which is the like and the like charges repel, for instance. So it's going to repel it to this direction. Okay. So supposing there's a small change in what? Charges, then there's a corresponding small change in what? In the electric field. Okay. So at point P, there is going to be a small change in the electric field, which is the dE as well. Okay. But let's look at something first. When we are talking about linear density, linear density is what? Is actually what? A ratio of the charge divided by the length. And here, per our assumption, the length is what? 2a. Per our assumption, the length is 2a. So our lambda is equal to what? Q over what? L. Our L is 2a. Okay. So that's our linear density. So now let's move on. Let's move straight to the what? So from the assumption, our L is equal to 2a, as I stated earlier, the length of the rod. Then our lambda, if our length is equal to 2a, then our lambda is equal to what? Q over 2a. Okay. But also, our length is equal to what? Our length is equal to 2a, and also our lambda, which is the linear density. The linear density is also equal to what? The change in what? Charges over the change in what? Dy, which is the y-axis. So these are the two formulas for lambda. All right. So from our assumption that L is equal to what? 2a, which is that whenever we see L, we are going to substitute it with what? 2a. But also, per our diagram here, our lambda is equal to what? If then our lambda is equal to, or the linear density is equal to what? Our change in what? Our change in charge over what? Change in what? The length, which is the y. Okay, that's how we are going to get our another lambda to be equal to what? Dq over what? Dy. So if you are having these two formulas, then we can equate these two. Okay, we can equate these two. That's what we are having here. So our lambda is equal to Q over 2a, which is also equal to what? Dq over what? Dy. From here, we can make dq the subject. If you make dq the subject, you are going to get what? If you make dq the subject, you are going to get q, which is this q. We are using cross multiply, so you are going to get what? Q dy all over what? 2a. Okay, so now we are having our dq. Now, from our Pythagoras theorem, if you look at this thing well, here is our x. Okay, here is the distance from the point with respect to the origin. This is our x. this is our y. For that matter, this is our r. From Pythagoras theorem, we all know our r square is equal to what? This s square plus what? Y square. Okay. So now, from our Pythagoras theorem, r square is equal to x square plus y square. But you all know our formula. Generally, our electric field is equal to what? Q all over what? 4 pi permittivity naught r square. So wherever we see our r square, we are going to substitute it with what? S square plus y square. Okay. So now our Q, our electric field E, okay, is equal to what? 4 pi permittivity naught, then x square plus y square, representing the r, or the radius. So now here we are having our electric field. Now let's suppose that we are having change in electric field. Okay, when we are assuming that DE, which is a change in electric field, that is change in E, then wherever there is a change in E, that is DE, then there's a corresponding change in what? Q. As I said earlier, wherever there is DE, there is what? DQ. So it means that from our formula, which is this formula, if you're having DE here, then surely you are going to what? A corresponding what? DQ. And this is what? Our DQ. Okay, so our DE is equal to what? DQ all over 4 pi permittivity naught r square. We know our r square to be s square plus y square. But we have derived our formula earlier on that dq is equal to what? Q dy over 2a. Okay, so now our de is equal to what? So wherever we are going to see dq, we are going to replace it with this one. So our de is equal to what? Q all over 4 pi permittivity naught, then dy all over 2a. dy all over 2a times the r. The r is s square plus y square. Okay, so this is it. So from here, from this portion, that's what I've drawn it here again. Okay, so let's say this is our point, then this is our de. So this is the formula for the de. Okay, this is the resultant what? Change in what? Electric field. So this is our de. Now how can we find what? Our dex, the x component of the what? The change in electric field, and the y component of the change in electric field. Okay, so now how are we going to do it? We just have to use our trigonometry ratio. We are having our angle here, which is theta. Then if you want to find the x component, if you want to find our x component, then we are going to what? Use what? Cos. So cos theta is equal to what? The adjacent, which is dex, all over what? Our hypotenuse, which is de. Okay, so from here, that's what I've written here. If you want to find our x component of the change in what? Electric field, then it's going to be equal to what? De cos theta, because cos theta is equal to what? Dex all over de. As I said earlier, the same thing also implies to what? Dy, but this time around our dy is going to be what? Negative, because look at the direction of the what? Of the electric field. It's directed towards what? The negative y-axis. That's why we are going to get what? Negative what? That's why we are going to get negative de sine theta. Okay, here the trigonometry ratio is what? Sine theta. Okay, so as you can all see, but when you are looking at our sine theta, as you all can see from the diagram here, this angle is the same as what? This angle. Okay, so from there, what will be sine theta with respect to this angle? Our sine theta will go to what? Opposite, which is this r over what? Y over r. Sine theta is equal to opposite over what? Hypotenuse, so y over r. Okay, the same thing implies to our cos theta. Cos theta is equal to what? X over r, which is the adjacent over the hypotenuse. So now, that's what I've written here. Sine theta is equal to y over what? R. But what's our r? Our r is equal to what? X square plus y square, or multiplying half. Don't be confused here. The half is actually what? A square root. Instead of me writing square root, or instead of you writing square root, you can just represent it as what? Half. The same thing applies to the cos. Okay, so here you see the reason why you didn't write the x square plus y square half is that it's square. Okay, the radius is square. That's why I didn't write what? Anything like half. But here it is not square. Here we are emphasizing on only r. So only r means we are going to find the square root of it, as in applied in what? Pythagoras theorem. Okay, so right now, as we are saying, our dex, okay, our dex is a change in electric field, the x component of the change in electric field. As you all see, this is the formula for it. The change in what? Which is the de cos what? De cos theta. But what's our cos theta? This is the cos theta. Okay, so wherever you see, the whole of this is dE. Just keep it in mind, the whole of this is dE. And the whole of this is the what? The cos theta. Okay, so when you are free, you can even pause the video and try and manipulate that formula again. We are going to get the same thing. So this is what? Our dE. The whole of this are dE. We've already derived it. And this is our cos theta from what we've made here. Okay, this is our cos theta. The whole of this is R. And the whole of this is what? X. Okay, so right now, our dEx, which is the x component, will be equal to what? We are going to multiply the numerator throughout. So kill x dy. That one is very simple to notice. Then all over what? The 4 pi permittivity knot. You see this one is the same thing as this one, just that the powers are not the same. According to laws of indices, for instance, if you are having something like A, okay, let's represent the whole of this thing as A. Okay, so A, and let's represent the whole of this as A. So A times A raised the power half. A times A raised the power half. What are you going to get? According to laws of indices, we add their powers. So you are going to get A 1 plus what? Half. And 1 plus half, which is what? 1 half. 1 half is the same as what? 3 over 2. Okay, 1 half is the same thing as 3 over 2. So that's how we arrive at this formula for the change in what? The S component of the electric field. This is how we came by. Okay, it's not a magic. It's here. Half. The half times what? This one. So let's consider this one as A. Let's consider this one as A. According to laws of indices, this is it. You are going to get 3 over 2, which is the same thing as 1.5 or 1 half. Okay. The same thing applies to what? Our dEy. So from our dEy here, we all know that what? It is changing what? Negative dE sine theta. And as you all know, this is our sine theta. Sine theta is what? Y over R. The whole of this is R. Okay, so we will come and substitute everything here into what? Our dEy. Okay, so right now we are going to get into what? The negative. The negative should always be there because, as you can all see, the negative is what? Pointing what? Downwards, which is the negative y-axis. Assuming it is in this direction, that's when you are going to get it to be positive. Okay, so always keep it in mind. Know the Cartesian plane. Okay, so right now, the whole of this is what? Sine theta, as you can all see. So we just multiply it, this one by this. We are going to get what? Negative ky, then dy, all over what? 4 pi permittivity knot 2a. This one will be multiplying this one because they are of the same structure. So this one, which is x squared plus y squared, x squared plus y squared. Just that what? The exponents are not the same. But according to laws of indices, we can derive it and arrive at this point that what? It is 3 over 2 per what I've solved here, or per what I've explained here. We can just arrive it at this point that what? 2 negative, because if you have something like A times A raised to the power half, then you're going to add, all what we need to do is what? Add their exponents. Okay, so the same thing applies here, and we had it with this formula. Okay, so that's all about what? Finding the change, the dy, finding the change in what? The electric field with respect to the y or with respect to the x. Okay.